All right. Well, afternoon, everybody. I know we're all anxious to get to SeaWorld and get things moving here. So we'll try to get through these slides, keep you all awake, and keep you engaged and focused in what we're doing here. Okay, a little background on us here. Hember Petroleum is a small company in California. It's an LLC, privately owned and backed. We're the first. This is the field that we're working on. Is the first field that we've actually operated as our own field. And because it was our first field, we also had to build it from scratch, from ground up. So there was nothing in the field. It literally was in the middle of a farmer's field. So there's no electrical, there was no pipelines, there was nothing there. So we're starting from ground zero, which is kind of nice because I can integrate my IoT and my OT at the same time and end up with a whole bunch of analytics that I want to see. So it's a great way to have things start. So background on myself, I worked for engineering for several companies, Freeport-McMoRan, Plains Exploration as production, and Reservoir Engineers. Worked my way up to be a manager for California, managed all the California properties. Did reserves, steam floods, reservoir optimization, production optimization, surveillance, so forth. So I have fairly technical background in oil fields and how they should operate, what reports and information to see, analytics, as well as surveillance tools. So that'll help us going forward with what we do. Okay, let's see. Okay, so before we need to talk about what we have at the field itself. What are we monitoring? What are we looking at? What do we have? So on site itself, physically, we have some tanks, obviously a couple of the wells, some separators, scrubbers, a flare, the D-high, and then a loading rack. So all of those all have to have different sensors for different measurements. So this is not California property, but it's not a steam flood property. This is a primary production property, which has high pressure gas. So in that sense, we are monitoring several items as we go along. So as well as with, just facility issues, we also have other issues that we had to handle with. That's what I'm saying. High pressures, high temperatures, elevated work surfaces, voltage. We had to get electricity to get out there. It's really a remote location. You have to drive to get there. If you want to be there, you have to want to be there. You can't just find it. So you have to really get there. You have to want to be there. Also being in California, you got to watch out for all the reptiles and bugs and bunnies that you have to be aware of to make sure that you don't endanger any of them or have any issues. Being that we're in the middle of the field, we are accessible for that, so we make sure that we abide by all the laws, make sure that everything is up to code and up to speed, and that everything is on the uprights, because we want to make sure everything's good. So traditional oil fields, I think everyone's rather familiar with. You've seen them. There are fields, there's wellheads, there's valves, there's equipment. Everything there is mostly manually operated. You have analog gauges, operators collecting equipment. The operators have to go there and manage the site. They watch all the flow streams. They watch the production streams. They're looking at the tanks. They got a little string they gauge the tank on. You hope that he hits it right. He's within a couple inches. You have 24-hour operations on your plants, your facilities. You got to have somebody there to monitor it. You got to look at it, make sure that it's all going well. You have local alarming. You have alarms, sounds, beacons, lights, whatever's flashing. That's probably where the operator is either running to or running from. So either way, he's reacting to it, but he has to be awake to pay attention to that. So you're hoping that at nighttime they're all paying attention to these things and well alert. Sometimes they are, and sometimes they're not. So it's one of those things. We're relying on the human spirit in that to make sure that they catch everything. Another thing is if there is an issue and he's running towards the alarm or towards the light, which is what you're hoping he's probably doing, you're hoping that he knows what valve to turn or what to do to shut it down to isolate what's going on. Doesn't always know. He's probably might just be running for his truck to head home or running to turn the valve. But needless to say, it's a mechanical issue that has to be responded to with a human person who should know technologically what they're doing and where they're going to help the situation. So this leads to a lot of other issues other than just operation. It also leads to data collection issues, which is where on the engineering side that you want to have clear and concise data. You want to know that the data came from there, and if you want to edit it, you can. When you do a manual collection, it's basically the operator walks up there, reads the number, and goes, I don't think that's quite right. Could be this instead. I feel like it's a 5, not a 10. And you can't do anything because he's written the number down, and then he manually inputs it into the system. So you're kind of filtering the data before you get it with the operator's collection, manually collecting stuff, as well as he's doing the manual codes and he's doing the estimated impact to production, what he thinks the well did, not what the well actually did do. So it makes things a little more fuzzy for where you're actually at. And so then from there, when you're in the office, you're making decisions based off of ideas that the operators put in, not what the actual real data set says. Okay, so bringing the new facility, we want to bring it into the new age of technology. I have an iPhone. I know how to use my iPhone. My daughter knows how to use her iPhone a lot better than I know how to use mine. So why can't I have everything automated and on my phone? because I should be able to do it, and that's what I want. That would integrate my IT and my OT together, and that makes things a lot better and easier for me. So I want to be able to measure everything accurately. I want to automate the well test so that the operators don't really touch it. They can see it, but they can't change it. I can reduce my manpower. I want to identify my production issues quicker, faster, sooner, so I can respond quicker, faster, sooner. Being a remote site, it's not like I have people there nearby, and so we have no existing communication. So I'm probably gonna have to put in some form of communications, as well as flow lines and a bunch of other stuff. But basically, looking at it, if we have the technology now and I'm building from scratch, why not use it? Why not go ahead with what we have? This is kind of where we should be at anyways. This is kind of like the standard of what things should be. And so going with that approach is kind of how we look at the facility. Like, if I have a facility, I should be able to control the facility from remotely or locally or so forth. So that's where we started building the facility. And this is where we helped with one of our contractors. We built it with Pros and Tyrion. Now David will come talk about a little more about what Tyrion was able to offer us.